Hello everyone and welcome to our next video on Simple AI with Python and Colab. And what we do today is we fit a split canvas picture. If you have an image that was split into pieces, how to assemble it again. We shall use Pyplot, Python image library and OpenCV to work with images, FastDTW as a distance metric. DTW stands for Dynamic Time Warping, Globe to work with Files panel, and NumPy as a mask to work with numeric arrays. Let's run this out. Next, I have 3 images of beautiful castles. Each one was split into halves by a vertical slice, so I have 6 halves. Let's take a look at them. For instance, this one and this one. So let's load them. We use Globe to run through content folder looking for PNG files. We turn them into an NumPy array, cut off the 4th transparency dimension and append to pixList. And then we plot our picture with Pyplot imshow. You see, there are 6 halves, so we'll have to make 3 holistic images, matching them horizontally. So the task is to find a good matching counterpart. And what is the key idea of how to do this? Let's first take a look at the image that was assembled the wrong way. You see over here there is a central part which was rotated 90 degrees clockwise. And we can see the clear distinct border. And the reason why we can see it is because colors inside and outside of the border, all along the border, don't match. And this gives us an idea that if we take colors all along the border and compare them, if they match, that most probably this is a good counterpart, okay? So first we will extract for each one of 6 pictures, for each one of 6 halves, we will extract left and right border and append them into borders list. But before that, we turn our pictures from RGB color system into HSV color system. HSV stands for hue saturation value. And this is because with RGB it is very easy to make mistake. If we, for instance, swap 2 channels, we will have the same metrics, but it will be totally different color. And this is less probable with HSV. So next we compare our borders, so we run through all the pictures, we take left border of each one and we compare it against right borders of all the other pictures. And we do it with FastDTW, so for each of the 3 channels we calculate metric, then we sum them all up, put them into DTW variable and append to matches list. Finally, we sort matches list ascending order by DTW so that best matches come first. The less is DTW value, the better is a match. Let's run. And finally, we take best matches and concatenate those image arrays to get the final holistic images. Let's run. You see, there are beautiful castles. You wanna live in one of them. And if we talk about real-life scanned images, they will have some color distortions on the borders, some shadows, so you will have to do some pre-processing to them. And best way is not to take 1 pixel width border, but maybe 3 pixel width border to eliminate the influence of those shadows and color distortions and take an average value for each pixel. Okay, so thanks for watching, thanks for being with me. Subscribe to the channel, subscribe to www.simpleai.net. See you, bye!